All right, this video is going to go over a review for, should say 6B. Sorry about that. It's going to be a long video, so let's go ahead and get started. These first 4 questions involve exponential graphs, so you're going to need to know these 4 shapes in order to do them. So this first one's a negative growth function, right? So it's a negative growth function. The shape of the graph is going to look like this, with the asymptote above it. All right. So that's the first place I'd start. The next place I'd start is with where that asymptote is. It's affected by these vertical shifts at the end. So if you don't have a vertical shift like we don't here, then it's on your x-axis like that. All right. And then the last thing is the y-intercept. So to get the y-intercept, you plug in 0 for x right here, plug in 0. So it's like -3 to the 0 minus 1. Well, that's -3 to the -1 is 1/3. So it's right here. And then you just make the graph take this shape. So it would look something like this. So your domain is all reals. The range, the lowest it goes is -infinity. The highest it goes is that 0 asymptote, just like that. All right, number 2. This is a positive decay problem. So it's going to take this shape. So it's going to look something like this. And here's your asymptote. Now this asymptote is at -2 this time. So it's at y equals -2 right here. All right. And then your y-intercept, if you plugged in 0 for x, you would get like almost -2, but not quite. It's going to be like this. So your graph's going to look something along the lines of this. Domain all reals, range, the lowest it goes is that -2 asymptote, and then it goes up forever. All right, number 3. This is a growth function, positive growth, so it's going to take this shape. So it's going to look like this with your asymptote right here. The asymptote's at y equals -6, so it's here. Your y-intercept, if you plug in 0, you're going to get 0. So this one goes through the origin. And then you just make the graph take that shape. So it looks something like that. Domain all reals, range, lowest it goes is -6, then it goes up forever. All right, and then the last one's a negative decay function. Looks like this. Your asymptote is at 2. The graph's going to take this shape with your asymptote right here. And your y-intercept, if you plugged in 0, you would get 1. So it's here. And then you just make the graph take the shape, just like that. Domain all reals, the range, the lowest it goes is -infinity. The highest it goes is the asymptote of 2. So that's graphing exponential. Now, applying these exponential functions, you need to use this equation. Where A is your start amount, R is your rate, T is time, and f of x is final amount. All right, so if they tell you they originally purchased a car for $6,500, that's going to be your A value. So this equation would look like this. Your starting amount was $6,500. Now the rate, it's decreasing, so it's going down by 10.5%. Well, 10.5% as a decimal is 0.105, okay? And then for your actual rate that you're going to put here, it's going to be 1 plus or minus that. In this case, it's a minus because you're going down in value. So when you do 1 minus 0.105 on a calculator, you get 0.895. That's your R value. And then to the power of t, the t is time, and they tell you 3 years. So if you punch this in the calculator, 6,500 times 895 to the power of 3, you get 4,659 and 96 cents. They say round to the nearest hundredth. That's 2 decimal places. All right, now number 6, we have the city that's growing at this rate. So 8.5% as a decimal is 0.085. So since we're growing, we're going to add that to 1 for the rate. So it's 1.085 is our R value. All right, now from 1980 to 95, they don't give you a specific time here, right? You have to calculate this amount of time yourself. Some people say it's 15 years. I say it's 16 years because if you count 1980, that is 16 years. So I'm going to go with time 16. Some people will go with time 15. I don't care. And then they say if the population was this in 95, that means that's your finished population. So here's what your equation would look like. 670,000 equals your starting amount times your rate, 1.085, to the time of 16. So you need to go get a value for this 1.085 to the 16. It's 3.6887. 3.6887. You can probably round that, but if the more you round it, the more your answer is going to be off. So like when you divide here, if you divide by 3.69 instead of 887, your answer is going to be off some. So keep that in mind. I just pull from my previous answer. I don't even type 3.6887. I type 670,000 divided by previous answer. So I get my answer of 181,634. That doesn't seem right, but we're going to trust it and move on. All right, this next one. You have this computer valued at 4,300 and it's depreciating. So it's going down at this rate per year. So 9.5% as a decimal is 0.095. Since it's going down, we're going to do 1 minus 0.095, which is 0.905. So this is my R value. And they want the computer's value after 4 years. That means this was our start amount. So it looked like this. F of X equals my start amount times my R value to the 4. So you can just punch this in, 4,300 times 0.905 to the power of 4. You get 2,884.45 dollars. All right, and then this last one, this guy's graduating from high school. He works this job. He took his very first paycheck and invested it. The money is increasing by 15%. Okay, 15% is 0.15 as a decimal. So it's increasing. So we're going to add that to 1. So you get 1.15 as your R value. At the end of 8 years, he had 16,500. That's your final amount. So we'll be looking for starting amount, A, 1.15 to the, they said 8 years. So you need to go get a value for this 1.15 to the 8. 1.15 to the power of 8 is 3.059. But again, I'm going to be pulling previous answer. I'm not rounding at all in my calculator. I don't have to. So you're going to divide now by 3.059 to get your answer. So let's see. 16,500 divided by previous answer is 5,393.88. Okay. Next page. We're graphing a log function. A log function by default comes up and makes a hard right turn like this. And it's got a vertical asymptote here. So that's the shape that these are going to take. So If they don't have a horizontal shift, this one has a horizontal shift. It's at x minus 1. So you would put that vertical asymptote at 1 because x is lie. This one does not have a horizontal shift. This minus 5 is not grouped with that x. It's a vertical shift. So this one's just on the y-axis here, x equals 0. Now, the way I teach these is there's a point where it makes a hard right turn, right? By default, it's 1 to the right on the x-axis. It only moves if you have like stretch or compressions, which we're not going to get that deep into it, but it really only moves if you have a vertical shift. So instead of being on the x-axis, it's going to be 5 down. So it's right here at 1, -5. This is where my line is going to make a hard right turn, just like that. So your domain is everything from 0 to infinity. And your range is all reals. So it goes down forever, up forever. All right, so where would that point be on this next one? Well, it's 1 to the right of the asymptote because there's no reflections or stretches or compressions. And instead of being on the x-axis, it's shifted up 3. So it's going to be 3 up right here. This is where my line is going to make a hard right turn. So it's going to come up like this, then not that hard. It's going to come up like this and turn to the right. And it keeps going up forever. So that's what makes the range all reals. The domain on this one would be everything from 1 to infinity. All right, now they want you to convert to log form. If you see convert to log form, go ahead and write the word log. Then you're going to snail it. So the first thing you've got is the x, that's your base. The next thing along the path is this 625 here. That's your of section. And then you finish with equals 4. So like this one, write the word log. Your base is a. The next thing is that k, that's your of, and it finishes at equals x. Okay, same thing to convert the other way. You're going to snail this, so it's like 64. The 2/3 is your exponent, and it finishes at equals x. And then this one, w to the power of h equals x. Okay, now they want you to evaluate these logs. That means to give them a value, all right? So first thing I do is I'd be looking for log where the of section is negative. Because if you have a log where the of section is negative, it does not exist. It's no solution. Like that. All right, now this next one's kind of tricky. So when you actually evaluate it, you imagine it equals x, and then you snail it like this. So it's like you're taking it to exponential form. 27 to the x equals 81. Well, this problem's a little tricky because you have to change these to where they have the same base. So here's what I mean. This is 3 cubed on the left, right? 27 is 3 cubed, so it becomes 3 to the 3x. And then 81 is 3 to the 4th. The reason why you want to get base equal base is because now you can set the exponential part equal to each other and solve it pretty easily. So this one's 4/3. Okay, this next one, if you snail it, it's like 3 to the x equals 1. Well, the only thing that would work there would be a 0. All right, the next one, if you snail it, it's like it says 7 to the x equals 49. You can make this 7 squared if you want. You don't necessarily have to if you just know that that's 2. All right, the next one, it's like 8 to the x equals 2. So this one you will have to change the 8 to be 2 cubed. Then you can set the exponential part equal to each other and divide and get your answer of 1/3. Okay, this next one, there's no base, so it's a 10 by default, and then you snail it, and so you get 10 to the 5th equals x. Well, you just give it that many zeros, 5 zeros. Okay, this next one, you get 6 to the -2 equals x. Well, the negative sends it to the bottom of a fraction, and then you square it, so it's like 1 over 36. This next one's really tricky. You're going to snail it. You're going to get x cubed equals 1 over 216. Sorry, x to the negative 3 equals 1 over 216. Well, 216 is 6 cubed. And then when you bring it to the top, it becomes 6 to the negative 3. So now you can just be like, okay, well, x equals 6. It has to be. And then this last one is like 9 to the x equals 9. Well, that 9 has a 1 on it, so you just set the exponential part equal to each other. This one's 1. All right, now we actually start solving, or no, we're still evaluating, okay. These you just have to do them kind of piece by piece. So snail this part. You would get 4 to the x equals 16, so that's 2. And then you snail this part. You would get 3 to the x equals 27. Well, that's 3. And then you had a minus in the middle to start off with. So it's really like it's saying 2 minus 3, which is negative 1. All right, this next one. When they have a number in front of it, kind of ignore it for a second. Evaluate this part. It's like 10 to the x makes 100. So it's 2. Now you can go back and be like, oh, okay, well, that 3 was in front. So I have to do 3 times 2, which is 6. Then this one, it would be like 2 to what power makes 1/4? Well, 4 is 2 squared, and then when you bring it up to the top, it becomes negative. So it's really like 2 to the x equals 2 to the negative 2. So this one is negative 2. And there was a plus in the middle to start off with. So it's like 6 plus negative 2, which is 4. All right, the next one, ignore the 3 in front for a second. Snail this part. So you get 3 to the x equals 3. So this one's just 1. Now you can apply that 3 that was in front. Now you can go get the second one. It's like same thing, 3 to the x equals 3 to the 1. So this one's just 1. And then there was a plus in the middle. So it's like 3 plus 1, which is 4. Okay, this next one, ignore the 2. You get 16 to the x equals 4. You're going to have to change 16 to be 4 squared. So it becomes 4 to the 2x equals 4 to the 1. So you can go 2x equals 1, divide by 2. This part is 1/2. Now you can apply the 2 from the front part. And so this whole thing becomes 1. 2 times 1/2 is 1. And then the second part's like 5 to what power equals 125? Well, that's 3. So it's really, this whole question is 1 minus 3, which is negative 2. And then the last one, this is like 8 to what power makes 64? Well, that would be 2. And this next part, ignore the 3. This one's like 5 to what power would make 1? Well, that would have to be 0. Now you can go back and do the times 3. Well, 3 times 0 is just 0. So it's like 2 plus 0, which is 2. I messed up this one. Okay. All right, now they want you to solve. So there's a couple different scenarios here. When you have log equal number, you're ready to just go ahead and snail it. So this one would be like 2 to the 4th equals 20x. So 2 to the 4th is 16. Now you can divide by 20. You get 16 over 20, which is reducible. It is 4/5. Okay, this next one. You can't evaluate something that has an x on the log statement. That doesn't work. So we have to leave the top alone for a second. We can evaluate the bottom though. The bottom would be like 2 to what power makes 8? Well, that would be 3. So really what you have is log base 6 of x, which we couldn't touch, over 3 equals 1. Now to solve this, you want to isolate this log base 6 of x, which means you got to get rid of this 3. So you get rid of the 3 by timesing by 3 on both sides of the equation. So now you just got log base 6 of x equals 3. Once you get log equal number, you can snail it, take it to exponential. So 6 cubed equals x. 6 cubed is 216. Okay, this next one. Evaluate this log base 2 of 8. That's like 2 to what power makes 8? Well, that would be 3. Now you can't evaluate this part. So really what you have, because it has a letter x, so really what you have is 3 plus this log base 3 of 3x equals 7. So to solve this, you want to isolate that log. So you got to move the 3. So now you have log base 3 of 3x equals 4. Now you snail it. So you go 3 to the 4th equals 3x. 3 to the 4th is 81. Then you can divide by 3. X equals 27. Okay, this next one. You have log equal number. So you're ready to go ahead and snail. So it's like you have 8 squared equals 4x plus 24. Change 8 squared to be 64. Subtract 24. Divide by 4. All right, last page. Now this one you have log equal number right from the start. So you're ready to snail. The problem is you don't have a base. Well, that base is 10 when it's not there. So really you have 10 to the 2 equals x squared plus 15x. 10 squared is 100. So now you have a quadratic that you need to solve. And when you try to solve quadratics, you want to make it equal 0 so you can try to factor it. Go towards the x squared. So I'd be minusing 100 here. You should get x squared plus 15x minus 100 equals 0. You do this so you can factor it. And then if you set each of those factors equal to 0, you'll get x equals negative 20 and x equals 5. And those would be your two answers. Now this next one, when you have log equal log, you can just set the of sections equal to each other. So it's really just like 3x plus 3 equals 18. And then just go solve. Subtract 3, and then divide by 3. X equals 5. All right, this next one, we have log equal log, so we're ready to just go solve it. 35 equals 5x minus 10. Add 10. Divide by 5. X is 9. All right, this next one, same thing. X squared plus 9x equals 36. Move the 36 because you want to go towards the x squared, so subtract 36. Now you try to factor it. So this one would be x plus 12, x minus 3. Set each of those equal to 0 and get your answers. All right, now this last one. They want you to solve these exponentials by getting the same base. Well, on 38, you could just dive right in and change 64 to be 4 cubed to the x plus 2. The thing is, you're going to have to distribute this 3 because it's power to a power. So this problem becomes 4 to the 5x equals 4 to the 3x plus 6. Now, just set the exponential parts equal to each other and solve. So minus 3x, divide by 2. All right. Now on 37, you can't change them to be base 9. 27 can't work like that. So you have to take them to base 3. So this is really like 3 squared. Now that's going to be the power to the power distribution again. So really it's going to turn into 3 to the 4x minus 2 equals 27 is 3 cubed. Now you just set the exponential part equal to each other and go solve. All right, 39. You can change them to be base 5s. So this guy's like 5 cubed. Power to a power, distribute it. 5 to 3x plus 18 equals 5 to the x squared. So now you'll do 3x plus 18 equals x squared. Go towards the x squared, so you're going to minus 3x minus 18. So you end up with x squared minus 3x minus 18 equal to 0. You factor it. Set each of those equal to 0 to get your answers. And then the last one, you're going to have to take both of these to base 2. So this 32 is 2 to the 5th. So this part, when you power to a power, you get 2 to the negative 10x. Now 16 is 2 to the 4th. So now you got negative 10x equal 4. Divide by negative 10. And you should always reduce. So negative 2/5 would be my answer. All right, there's your test review. Hope this video helped.